Namaskar and a very warm welcome to all the viewers in today's live and interactive session present by CIET NCERT. My name is Rajan Rajput. Here on the screen we have joined by sign language interpreter Nirbhay. Mr. Nirbhay, we also want to welcome you. In today's session we are going to learn subject science for class 8 students and topic is light, mirror and lenses part 2. So, this is going to be very interesting in today's session. We are going to learn. You all are watching us this session on PM Vidya channel number 8 along with on our official YouTube handles. These are NCERT official and NCERT PM Vidya class 8 YouTube channel. You can also join us through the various medium. You can also contact us through the IVRS number and the number is also flashing on your screen and number is 8800440559. Through email ID you can drop your queries and comments and questions as well. So, email ID is dth.class8@ciet.nic.in. And the viewers who are watching this session on NCERT official YouTube channel, so live chat box option is there to drop your comment and queries. Without any further delay, we have this half an hour to discuss with Miss Priti Maan, TGT of Science subject from Bharati Public School, GRH Marg. Ma'am, namaskar and a very warm welcome.
Thank you.
So, ma'am, this is, yes, the question is what we learn in part 1 and what are the learning outcomes for part 2 we have.
Okay, so we'll quickly discuss that what we have discussed in part 1. So, part 1 it majorly covered about mirrors. So, we have seen that light when it travels in a straight line, the path is straight, we call this property as rectilinear propagation of light. Further, we have seen that whenever it is hitting a surface, so what happens? So, the observation changes when the surface is shiny and if it is rough. Further, we have seen that what's the difference between the image formed by a concave mirror and a convex mirror. Right, for concave mirror, we get 6 observations wherein the image formed changes from real and inverted to virtual and erect. And about convex mirrors, we have seen that how convex mirrors are forming images which are virtual and erect. We even saw the properties of plane mirror, the one which we see every day, right? So, what were those properties? That the image formed by a plane mirror, it is laterally inverted, it is erect and lateral inversion occurs, right appears to be left and left appears to be right and it is of the same size. Now, today we will be discussing about how the light is behaving when it is hitting the surface. Okay. So, we will quickly start up with today's session. So, first we did talked about mirrors, right, plane mirror, even convex and concave mirror, how the image formation is taking place when we talk of mirrors, right. So, there is one more term here, reflection. So, what is reflection? It is the bouncing back of light. So, whenever light rays are hitting the surface of the mirror, what happens to them? They bounce back and this phenomena is known as what? Reflection.
Okay. So, ma'am, what happens when light falls on a mirror and what is reflection?
So, we'll study this by using an activity because it's more convenient understanding that way.
Okay.
So, before that we need to be very through with these terms. So, the first term is incident ray. Okay. We'll just quickly see what the terms are: incident ray, normal, reflected ray, angle of incidence and angle of reflection. And all these terms, they are there on a plane mirror. So, what exactly happens, right? Incident ray is the one that is falling on a mirror. The ray that falls on the mirror, what do we call it as? The incident ray.
Okay.
So, what we have said in reflection, what is happening? The ray is bouncing back. So, when it hit the surface of the plane mirror and it moves or it bounced back in the other direction, that ray is called as reflected ray. right? The
Right.
difference is clear. Incident ray is the one that is hitting the mirror from the source, it is coming and it is hitting the mirror. Now because our mirror is shiny, the surface is shiny and smooth, it is getting reflected, and on reflection it is moving in the other direction. Then we have this one more ray that is called as normal. Now normal is perpendicular to the surface of the mirror. Clear?
Yes, ma'am.
Next is angle of incidence. What is this angle of incidence? It's the angle formed between the incident ray and the normal ray. So this I is angle of incidence and R is angle of reflection. So angle of reflection is formed between the reflected ray and the normal ray.
Okay, ma'am.
So that's how we understand the terms that further has given laws of reflection, which are very important. Okay, so what law of reflection says?
So, ma'am, are there any rule to understand reflection better?
Yes, so laws of reflection are the rules with the help of what we understand these terms better. So the first law, what it says, that angle of incidence is equals to angle of reflection. Now whatever is the angle formed here, okay, the same angle should be formed after the reflection. The second law states that the incident ray, the normal and the reflected ray at the point of incidence, yes, this is the point of incidence, they all lie in the same plane.
Okay,
Right?
ma'am.
Hope
You're
that's
right.
clear. The incident ray, the reflected ray and the normal ray at the point of incidence, they all lie in the same plane. So all three of these rays are meeting at a point that is called as point of incidence over the mirror. So these two are, we can say that these two are the rules which the light rays are following and giving us these laws of reflection.
So, can we do some example? Can we take some example for to understand this better?
Yes, because this concept is very important. So student should practice the numericals which are given in the text. We also have one example over here. So you just have to see this figure very keenly, observe it, what's happening, right? So what it says, the diagram shows a light ray hitting a plane mirror.
Okay.
What would be the angle of incidence and reflection, right? So you really need to understand it, that this angle that is 30 degree which is getting formed here, okay, and I'll show you that how we go about this. So we'll make the same diagram in our notebooks and we'll make an imaginary line. This is the normal ray, and in the question it is given that the incident ray, this angle formed is 30 degree. Okay. Now what we have told, that normal is perpendicular to the plane. So if I just simply name them, it will be easy to understand. So this AOC, angle AOC is how much? That's 90 degree. And if I mark it as B, so angle BOC is how much? 30 degrees. Angle BOC is 30 degrees, right? So this is 90, this is 30. So it's very simple calculation. What will be this angle? We subtract these two.
Yes.
And what do we get?
60.
60 degrees, right?
Right.
And 60 degrees what? Angle AOB. So this angle AOB is 60 degrees. So we got our angle of incidence. Yes?
Yes, ma'am.
That is 60 degrees. Okay. Now as per the rule that we have studied, that whatever is your angle I, same will be your angle R. So if we are getting angle I as 60 degrees, so what should be angle R?
Yes, 60.
60 degree, right? Now if we see the question back, over the screen. So, which is the correct option out of these 4 which are there? So, the correct option is the D part, right?
Right.
Wherein we have found out that angle of incidence is 60 degrees, so is the angle of reflection. So, we will quickly see that also. So, we have seen theory that what happens, how do we find out? We will just see it that whether it is actually happening in real. So, we will conduct this activity.
Okay.
So, this is plane mirror, right, the properties that we are talking about, and here I have drawn all the necessary rays. This we have to assuming that this is the plane mirror. I will place the plane mirror here. This is the normal ray, right, and I have made some angle, so normal and incident ray, I have made some angle. So, we just have to really find out that what that angle is. Clear?
Yes, ma'am.
So, we will place our mirror over here. It is not getting supported. I will hold it in my hand only, right. So, this is what is the experimental setup where we verify the law of reflection. Now, what do we do next? What we have seen in the law that the angle of incidence is equals to the angle of reflection.
Yes,
clear?
ma'am.
So, we incident the light over the plane mirror at some angle, and if you see, is it visible that
no,
it
ma'am.
is no, the light is not that prominently coming out. So, if this
The student may revise this at their
yes,
home.
if this white point is visible to you over the screen, see the light is hitting, though it is a laser light, but it is appearing to be white over the screen, right. So, here, right.
Okay.
So, what we will do, we will mark that point. This was the place where I saw the reflection of this light coming. Now, what I will do with the help of this, I will measure that what is the angle formed. Okay.
Okay.
So, this is coming out to be 40 degrees. And guess what? The observation is exactly the same, because the angle that I have taken for incidenting the light, it was 40 degrees, this angle, right. And what we did, we incidented the light, right, and it got reflected. We noted from where the reflection is coming out, and this angle is also 40 degrees, right.
Right,
So, we
ma'am.
have seen in the theoretical numerical also, and with the help of this activity also, that yes, always angle I will remain equal to angle R.
Okay. So, what are the lists? We can take some quick review of this again, ma'am, please.
Okay. So, these were laws of reflections. Yes. So, children should revise that. Again, we will say that what are those statements, that angle of incidence is equals to angle of reflection,
Okay.
incident ray, reflected ray, normal ray. At the point of incidence, they all lie on the same plane. So, this was about mirrors, right.
Okay.
We do have certain surfaces from which the light is not getting reflected,
Okay.
but what happens, the light passes through them, right. So, that is how it is happening in mirrors, right. Plane mirror, the light is getting bounced back. In concave mirror, you see concave mirrors are the converging mirrors, you get your image upside down, and convex mirrors, what happens there? So, the light ray gets diverged. Yes. So, that is how within different 3 cases we get different type of images that are formed.
Okay, ma'am. So, what are the other surfaces from which light passes through?
Yes. So, those other surfaces are what? They are the lenses. We did
Okay.
talked of mirror, plane mirror, concave mirror and
Yes.
convex mirror. We know in mirrors what happens, that one side it remain polished. Yes, but in case of lenses what happens, they are not polished but you can see through and through, right? Like your glasses. Your glasses are what? It has some sort of lens present in it and we can see through and through. So that's how we define lenses, that it is a piece of a transparent material. Either it is made up of glass or it is made up of plastic, and they have got curved surfaces, right?
Right.
So we'll talk about these lenses also. So the lens which is thicker at the middle as compared to the edges, that's called as convex lens. Okay. So we have the lenses also. Before that we'll quickly see what's the other lens. So the another one is, it is thicker at the edges as compared to the middle, and that is the concave lens. Okay. So I have these two lenses with me here, right? As per the definition we can see that you can see through and through out of this, right? So by touching the surface you can identify that you are holding which lens, right? And if you just touch it and tell me.
So
that
this one is convex
yes,
and so other one is concave.
this is concave,
ma'am.
right? So you very quickly you have identified that which one is convex and which one is concave, right? The touch only tells you. So the convex mirror, what happens to it? It is thicker from the middle, right?
Okay.
And the convex one, it is thicker at the edges. So when you touch it, you can easily feel the difference between these two. Now further talking about these lenses, what happens? We'll see that how the image formed by convex lens it appears. Okay. So like in case we have seen for concave mirror, right? Concave mirror has got 6 cases, wherein when we have changed the position of the object, the nature of the image formed also got changed. So the same is happening here also. Convex lens has got 6 cases, wherein when we change the position of the object, the nature of the image formed changes, right? One more point to note here is the image formed by convex lens, it is real and inverted image, right? I hope you know the meaning of it, because we have discussed that in the previous class. Real image is what? The one that is obtained on a screen, and inverted image is upside down, right?
Right.
So the cases we'll see here, what are those 2 cases? When the object is placed behind the convex lens at a small distance, right? So we see the image formed to be the enlarged one. So that we can really see over here. If you can see the change, right? 30 and with the lens, right? There's a difference.
Yes, ma'am.
So we see this 30 enlarged. It is bigger in size, or 30 or 60, whatever is visible clearly. It is enlarged in size as compared to this. Why is this happening? Because of the distance, right? Distance between the lens and this is what is the object. So whatever we are getting, the image is the enlarged image. Okay. Second case, if we see for this, now in second case what happens? When we keep the object away from the lens, so it appears to be the inverted one. So for that we really need to be having an experimental setup. That is not possible, because we really have to keep the object at some distance. But that's how they differ. Okay, you can see on the screen also how the image formed is different. When the object is placed nearby, you get an image which is erect and enlarged. You get a big image. And when the object is placed at some distance, right, the image is small as compared to the object, and it is inverted upside down, right? So do keep this point in note somewhere that whenever we talk of convex lens, there are 6 cases wherein we keep on changing the place of the object, and based on that we get the image formed. Now further talking is concave lens. Okay. Now concave lens, what happens in here? So that's how the image is formed. You can see the picture. I have taken the same picture for comparison of all 3 cases. In this case with concave lens, what is happening? The image form is always erect, right? Erect. So you need to be underlining that it is erect. It is small in size, right? So that's how we see the difference between a concave and a convex lens when the image is getting formed. One more point, that how do we find out the difference, that yes, there is a difference between these. It is that when the light ray fall on these lenses, what happen, how the light ray behave. Okay. So we quickly have the points over the screen. So the first case, when it is a thin glass plate,
Okay.
the light rays go parallel to each other, right?
Right.
When we have convex lens, the one which is thick from the middle and it tapers from the sides, what happens? The light rays are getting converged. So convex lens is a converging lens. It brings the light rays at a single point.
Okay.
Moving ahead, if we replace this with a concave lens, okay, what happens? The light ray gets diverged. Now we can clearly see the difference between the second and the third case. In second case, the light rays are coming to a point, and in this the light rays are going away, they are getting diverged. Okay, so that's how, by just holding the mirror in our hand also we can find out that which one is which, because the light rays when they are getting converged, so you can have sun as a reference and you can bring in a convex lens. When light ray passes through it, you see a point, and if you keep it for some time, you may see that the paper can also start to burn, because yes, all the light rays are getting converged at a point. And further, where we are using it, so these are the places where these lenses are used. We use them in binoculars, we use them in camera, microscope, telescope, and the spectacles that we wear. So with this we wind up the chapter. The questions in the back exercise are very important, so children do go through the questions. This complete learning from the session will help you out to do those questions very quickly, right? Because I made sure that we cover each and every point which are there in the text.
Thank you so much for this wonderful informative session. We have with Miss Priti Maan, TGT of Science subject, Bharati Public School from GRH Marg. Ma'am, thank you so much. Thanks once again.
Thank you.
And in our next session at 3:30, we are presenting for you. We are discussing mathematics, and topic is we distribute yet things multiply part 2. At 4, for channel number 6 to channel number 12, we are presenting webinar session for you, and at 5, Sahyog session will be there. Stress versus you, who wins the science of resilience is the topic for Sahyog session. Thank you so much, Mr. Nirbhay, to interpret this whole session. My name is Rajan Rajput. Time to signing. Thank you so much.